All right, Ariana, this one's for you. Here are the 14 questions that I gave you to do for that midterm. And so you're gonna see me looking at my computer screen over and over and over again because I've got them right here. So I also sent you the answers, but just to give you a little bit extra because I just don't want you feeling confused. So you look at the one on the chart that I circled, and the very first number is here, plus I changed that percentage to a decimal, and then the parenthesis starts, and this is where you put the income. So because it says the income is 96,775, I put that right there, and then you subtract. Make sure you use parentheses. Try not to be using your cell phone calculator. That's why I suggested you went and got one from Mr. Babb. And then you'll see that answer there in the answer document. All right, number 2 is literally add. So question 2 is literally just add up all those numbers on a calculator. So we need kind of proof that you're working, but we don't need to make every problem difficult. Number 3, when you look at the answers, you're gonna use the pension formula. So the pension formula is some percentage multiplied by the number of years multiplied by the average salary. There's the formula you're gonna use. So write that down. I don't know that it's written anywhere, it's not on the formula sheet. So write this down for pension. So for the average salary, that's why I have those 3 numbers added, and then divide by 3, and it's inside parentheses so that the calculator knows to make one number out of that, and then multiply by the number of years, and then multiply by the percentage. So hopefully you have the answers right there next to you while you're working this out. All right, next one. Next one says, you're probably not, there's little chance you remember this question from the spring, but next one talks about your interest compounding continuously. And when we talked about that continuously, when you see compounded continuously, that's your key that this is your formula. And in class we called that the PERT formula. So this is what you're putting in the bank, or the principal. So in this question you're putting what does that say? $5,800 in the bank. And then you hit E. E is the button on the Casio. There's one that looks like this, and then above it is E to the X. So you have to find that button on the Casio. You'll probably have to hit the shift key, or on your calculator hit the 2nd, or on your phone calculator. In any event, that will pop up. Depending on the calculator you use, the little hat will come up for the exponent. The rate is it's really annoying. It's 4.2, oh, it's not that bad. 0.042. And we're putting the money in when he's 22, and we're taking it out when he's 55. So that is 33 years that money is gonna sit there. And so that is where those numbers are coming from. And then you'll see the answer right there. It's kind of long. All right, ending balance after 6 months. Question 5. So this is just the normal compound interest formula, question 5. And it's B equals P1 plus R over N to the NT. And again, make sure you use parentheses around that exponent, otherwise the calculator won't know what to do. So this is super straightforward, just plug everything in. So we're putting 1,900 in the bank, 1 from there, plus Our rate is 0.0325. It says we are compounding it weekly. So I'm gonna write 52 because there's 52 weeks in a year. So this is weekly. If the problem on the midterm said like monthly, it would be 12. Yearly is just 1. Quarterly is 4. Daily would be 365, and so on. Okay, so this is weekly. And then the N is 52. And the time says 6 months. Don't put in 6. The time is considered to be the number of years. So 6 months out of 12 months is half of a year. So here you can put 6 over 12, or you can change that to 1/2. Or you can put in 0.5. Your choice on how you write that. Plug it all into the calculator and you'll see the answer that I came up with. All right, number 6. If you put money into your bank every single month, your bank account balance is constantly changing, not only from the interest, but your bank account is changing because you keep adding money to it. Every single week or month or whatever it is you're doing, you're making more and more money. So this formula is a little bit more complicated. And so this is how much money we're putting in the bank. And then you can just see for yourself where that comes from. You just have to make sure that you're typing it all in. And so double parenthesis here, 1 plus the rate, I should have come up with a better system here, over the monthly for 12, and then to the NT, and then there's a -1. Now, this opens and closes here. You don't have a close to those 2 parentheses, so you need to double that right there. Divided by R over N. So divided by 0.023 over 12. So this is the deposit that happens over and over and over again. So find the formula that matches that, plug that all in, and you'll see what the answer is there. All right, job 1, job 2, question 7. Job 1, job 2. The first one is just 35 grand a year. So you might just want to scribble out what that looks like. Job 2 is $18 an hour, working every week for 36 hours, and there are 52 weeks in a year. So we end up with 33,696. It doesn't even matter because this number is less. So that number makes more, and that's all I ask you to do for that one. All right, so that is the first 7. And now I'm gonna need to go to the next piece. Bear with me here. So midterm review answers 8 through 21. Says it's pulled up already. There it is. Okay, so number 8, Sarah wants to take a trip to Thailand. Notice the formula. So how much money does she need to put in the bank now so that she has a certain amount of money later? How much, look at how it's phrased. How much money should she put into an account now, one time, so that later she has $7,300? And so I think if you understand that now and later idea, that formula, now that I've done a few of them, hopefully makes sense to you. So, and then Jim and Teresa, I cut that one out for you. John and Linda. All right, The next one you should see should talk about John and Linda. The difference between this problem and the last problem is they're going to put money into the account over and over and over again. Over and over and over is called periodic. And so when they put money, they want to know how much money they should put in over and over and over so they have that certain amount later. So this is a tricky formula, but it's no trickier than the one that, the other one that's over and over and over again. So again, we're putting, no, scratch that. We want this much, and this is our rate, and it's 26 because it says bi-weekly. So that means every 2 weeks. So if there's 52 weeks in the year and you get paid every 2 weeks, that's 26 times. So that is where that number is coming from. Divided by, and we double that right here. And so we have 1 plus 0.034 over 26. And then we have the n, and the time is 14 years. And then the 1 here is part of that formula. And so you can see on the answers, it would mean that they would need to put in $257.62 not twice a week, every 2 weeks, bi-weekly. This is how much money they would have to put in the bank. All right, number 11. You're simply going to add up. I think I do a pretty good job of explaining what to do on number 11 on the answers. You're just going to add those up and multiply by the rate. Number 12, it's not your number 12, the one about the resumes. I took off the part that says write the piecewise function. So you can come up with the answer however you want. So how much does it cost to produce 90? Well, if you want to produce 90 resumes, the first 18 are going to cost you $12.99. I believe it is. Yep. And now you have 72 left to pay for. And they come in groups of 9. So 72 divided by 9, you need to buy 8 more groups, or 8 more sets, and each set cost $2. So 8 times 2 is 16. So the answer to this is $28.99. You can probably think through that a little bit differently and still come up with $28.99. Since I'm not making you write out the equation, it's however you want to think of it. Okay, so you just do whatever works. All right, 13 is a very, no, again, I have to stop using the numbers. Jake gets 5%. I think the answer kind of speaks for itself, but let's go through it. He gets 5% on the first 5,000. So whatever those two numbers are that are given to you originally, 5% on the first 5,000, and then plus 15% on the rest. So anything over 5,000, which is why we have to subtract his total and the 5,000, because he already got paid for that right here. And so just figure those two pieces out and add them together. Or just have your calculator do all of the work and add them together. Either way. All right, the next one on my page we skipped. The next one is a little bit of work, but on your final project I want you to do, you're gonna have to do this also with your salary. So it's good to kind of review our taxes. So he earns $10.95. So $10.95 for each hour. He works 40 hours a week. He is paid after 2 weeks of work. And so that number is 876. And then we have to subtract Social Security, my bad, Social Security and Medicare, and then all of the other things that are listed, federal, state, and healthcare. And so each one of these numbers is going to be a subtraction. These three are listed for you right in the question. So the only really thing to calculate, other than the subtracting piece, are these two. Social Security is always 6.2%. Medicare is always 1.45%. So these numbers will depend on that. So to figure out the Social Security, go 0.062 times 876 and put that number right here. So you can tell on my answers it looks like it's 5431. And then we're going to do the same thing here, except for we're going to change that percent. And it looks like that Medicare number is 1270. And then subtract all the ones in the problem, and you've got the answer right there in front of you. All right, next one. There should just be a few more. The next few that you see on the answers are the stock ones. I didn't include those. I did include the Mike problem and the Megan problem. The Mike problem is like what I was talking about today in class. You subtract the two, so you get the change over the original. In class, we called that today minus yesterday over yesterday. So this is the change over the original. So the change 7,100 minus 4,600. My only advice here would be to make sure that's in parentheses, and this was originally that. Don't forget to move your decimal. So you're going to end up with this, and you're going to move that twice. And so it looks like that. All right, number 20 is a lot, but you're going to have to use that monthly payment formula on your final project I gave you. If you need it for, like, if you take out a student loan in your project, or if you have a car payment that you need to calculate or something like that. So not every project would use this, but find that monthly payment formula. And I gave you a formula page, and it should be right on there. And so hopefully it kind of just translates. Let me just go through it. So the monthly payment formula is the principal, start with parentheses, multiplied by R over N. Oops. Oh, I think it's R over 12, my bad. And then 1 plus R over 12 to the 12t. And then we have to close up all of our parentheses. So I think it's just 1, yep. And then we double it. 1 plus R over 12 to the 12t minus 1. And so you can match this formula with the numbers you see plugged in there, and it should make sense. The rate is 7.8. So every time you see that, and the time is 20 years. So you should see the 20s in for the T's, and you are borrowing $45,000. So use this practice guide as needed, and then try the midterm. And that will count as one of your test grades that you were missing from the spring, so that should go and plug into a big chunk of raising your grade from the spring semester. So that's all I have to say. Good luck. Let me know how I can help you. Take care.